with software people browsing the website. So when it comes to consuming a service, this client is very broad. The client may be browser, it may be hardware, it may be mobile phone, it may be even Palm Pilot, or so in a broad sense, the client is anything that consumes a service. On the server side, you see that SOA services are composed of cloud computing and grid computing, platform-oriented architecture, software as a service, web-oriented architecture, and platform as a service. And these are individual terms that we will learn as we move on. On the client side, we see only two parts. One is the Web 2.0, which applies to browser-based application and service-oriented architecture-based clients, in which they consume one of these available technology services. And as you can see here, it can be either both server, hardware or software. And to consume web services or SOA, we need REST or web services. Now we will go details on each of these technologies very briefly, shortly. All right, next slide. Why service orientation? As I explained, service orientation takes the expenditure away from people who just wants the service of that software instead of installing them in a server, installing and maintaining a data center, connecting their server to a high bandwidth internet backbone, and then pay for electricity. Managing a service software is costly thing. Now, cost saving. What cost saving does somebody come when it comes to service orientation? Hardware requirement change over time. One of the important thing is, as we see that every year we come up with a new and powerful processors, new and powerful servers, bigger hard drive, bigger memory, and ever decreasing price of hardware. All these have to be maintained by the service provider. So if the service utility, the software which provides the utility, is offered as a service, then the service user doesn't have to worry about this hardware replacement and maintenance. Network bandwidth. Network speed is also changing, and some applications require very high bandwidth. For example, a bank probably need hundreds of megabits of speed when it comes to communicating with the clients, with their clients over the web. On the other hand, just simple application, like for example websites, may just need 10 megabits of bandwidth. All these bandwidths, somebody have to pay for those bandwidth, and offering these software as a service eliminates the bandwidth purchase. Scaling is needed as business grow. In a cloud computing, which we will discuss later, multiple servers are used, and these servers are very large with a lot of memory and a lot of hard disk space, and they are scaled using virtualization technology as the business grow. Complex applications have to be written once. This is probably one of the most important part, is that once we develop the application, usually these take many years, and they just have to be maintained once for a particular hardware. Maintenance part already comes from the software development, because software development requires maintenance. Data center, as I said, that data center maintenance can be eliminated, and easy integration with other application. Once the software is running as a service, it can be easily integrated with our other applications also running as a service. The basic technology on which service-oriented technologies are based upon is called service-oriented architecture. Now, in this 1 hour, what we are going to learn? We are going to learn about service-oriented architecture and two implementation. Current popular implementation is REST and web services. These are part of service-oriented architecture implementation. The REST means representational state transfer, and web services is also another standard for realization of SOA. Cloud computing, grid computing, and SaaS, or software as a service, PaaS, platform as a service, POA, platform-oriented architecture, WOA, web-oriented architecture, and Web 2.0, which really is a vague definition, which we will see later in our discussion. SOA, service-oriented architecture, is a basic concept of in our entire discussion. Our discussion is based on service-oriented architecture. SOA. What is SOA? SOA is a computing model based on loosely coupled interoperable services. A loose coupling assures that services and consumer could bind and unbind remotely using a well-defined protocol. In web services, this protocol is SOA. In REST, this is just XML protocol. So loose coupling assures that regardless of where the client and server is, the client can bind to the server using a loosely coupled protocol, and the service have to be written in such a way that it appears stateless from the perspective of the client. Interoperability assures that applications, once written, is usable by various platforms. That means that once we finish up with the application for the web, any platform means that mobile systems, PCs, mainframes, hardware, and other software may use and consume the services offered by that service indifferent to the platform's use. For example, mobile devices use less powerful hardware than a PC. On the other hand, mainframes uses much more powerful hardware than any other things, any other platform. So regardless of what the client technologies or hardware platform is, the interoperability assures that the services offered will always be consumable. SOA could be hardware and software both. And SOA does not define any technology. It is just an architectural pattern. And we will see that SOA in general is just an architectural pattern, but there are two methods right now, as web services and REST, the two approaches that someone can use to realize a SOA implementation. Applications written using service-oriented architecture methodologies have to be deployed on a server, software-based, or is a server hardware, which also serves as a service. The example of server-based SOA is Soalib, which is our company's product, and a lot of other software are out there from various other SOA vendors. And for a very good example for a service-oriented hardware is IBM's Data Power, which provides XML acceleration as a service. WOA, web-oriented architecture, is simply limiting the view of SOA and including an HTTP over REST protocol. Now, in our first slide, we saw that the cloud computing is a composition of grid computing and service-oriented architecture. Now this one is, in this slide, we are going to explain what really is grid computing. Grid computing is maybe thought as power generation, these power generation stations here, maybe thought as servers, and these home power consumption area may be thought as consumers, and these lines may be thought as just internet connection, and these towers may be thought as routers. Now let's see what happens. In the next slide, we did just what I explained. The power stations are converted into servers. The houses, the power consumption is converted into service consumption. The towers are converted into routers, and the connectivity is still wire. Now it can be also wireless. Now, what advantage is there when we come to grid computing? Let's see. When it comes, when we use grid computing, excuse me, there is some locking on the screen. All right. Now, grid computing allows scaling applications or servers or resources in general. In our example, in the previous slide, we saw that we have servers independently running. Here, servers are independently running on, for example, this one, and then there are 3 servers independently running. How can we combine the power of all these servers together, which grid computing allows? It can be done by software. Software and hardware together can combine multiple servers together, appearing as one single server, which is called scaling. And that's where cloud computing comes, because when we say cloud computing, it adds scalability and also a software layer. So what is cloud computing? Cloud computing is grid computing plus service-oriented architecture. A service-oriented architecture provides a software stack usually, but also maybe hardware, and the grid computing provides the hardware stack. So in this slide, we saw that the 2 servers we saw at the bottom, see the 2 servers we are seeing on the bottom right are now combined as one single server, called multi-server scaling, using software and hardware, which you never see as a service consumer. These are the data center specific, and you never see those scaling automatically happening as services are consumed. But the application developers and the SOA developers have to develop those applications based on these services and based on this, what I would say is hardware and software platform, but from the perspective of the client who is consuming the services. So for example, the clients here, these clients will never see that these servers are getting scaled automatically. All they see is that the service they have requested are getting processed. Now SOA in the cloud, service-oriented architecture, is the software for the cloud computing. The cloud computing is maybe thought as the platform for SOA. In this slide, there are A, B, C, D, E, and F. So there are A through F services being offered on the cloud, and there is a consumer on the left, which is this consumer, may consume any services. Now, this line, this is an imaginary line. This is an imaginary connectivity pattern. It may be thought as a bus, as some kind of bus, which we will discuss later as enterprise service bus. This is an imaginary bus in which each of these services connects to in order to provide the services. Each of these services must have to follow a well-defined protocol. And a well-defined, it can be well-defined or it can be proprietary. It does not really matter as long as the consumer knows how to call and retrieve and also use the services. So this imaginary line may be thought as is some kind of bus which connects all the services to the service consumer. Web services and REST, as I said, discussed a few minutes ago, is that SOA can be realized with web services and REST. Now here we are trying to explain web services and REST technologies. Web services is a specification to build SOA using the SOAP protocol. This is probably one of the hot topic these days because web services specification, everybody is familiar with the web services, very highly complex specification that somebody have to study when they want to implement web services. But there is a good part and also bad part. The good part is that once somebody understands, once the application is developed with based on these web services, it's available on the cloud and it's already developed. People have spent the money and time. It's now available for consumption over the cloud. The expense is just one time. On the other hand, the client have to be WS star ready to consume and use the feature provided by the web services star specification. Services are discoverable, so web service is a discoverable service. On the other hand, REST services are not usually discoverable, but there are other approaches like WADL, which may be used to discover REST services as well. REST is representational state transfer, is a model used in computer science, which is developed by Roy Fielding in his PhD thesis, which may be used to implement SOA. And REST, which I will cover later in one slide, is uses HTTP and XML. Now, how does a web service discovery work? Web services discovery works in the following way. Is a server, one server is trying to consume another server. Now, this A can be both consumer, A can be consumer and also server itself. It can be also be a service. Would like to consume service offered by B. Now, B is a service that provides some API, what is called the WSDL document, in which it describes how to communicate with and use the services of B offered by B. And it publishes these services in the WSDL document into a global registry called UDDI registry. A doesn't know where B reside. So it goes to the registry, tries to find where B resides and how it can communicate with B. So A goes to the registry, fetches the WSDL document. In addition, it also fetches other documents like schema, technical documents, provider information, security information, all these, which is stored in the UDDI directory. Fetches those documents. The WSDL is used for generating the stubs required to communicate directly with B. The WSDL also contains where exactly, what URI, at which URI that B is being hosted. So A gets all the information of B, and now it can communicate and call the services offered by B. So that's basically the triangle that you see here, this little triangle, which is a famous web services triangle, discovery triangle we say, as you often see in web services. Let's focus on REST. Now, REST doesn't have this discovery, but let's see how it would communicate. In a REST service is a service based on HTTP protocol. and it communicates XML data. Server can accept and send XML data, and the consumer can also send and accept XML data. The consumer invokes these services: get, post, put, and delete services for the service. Because this is hosted as a HTTP service, the HTTP have get, post, put, and delete. It understands those protocol. In this example, consumer 1 is sending some customer information. What is your name? What is the phone number? And the service sends the data back. So I just made a mistake here. The customer sends the customer information, and this GET request on the top you are seeing can be used to retrieve data. So based on what service somebody is using, these GET, put, post, and delete messages, and what it means that somebody have to individually define each of these get, post, put, delete service messages for the service, and utilize those messages to invoke or retrieve data from the service. And all the communication between the service and the consumers are XML. Now, SaaS is another term we discussed that we are going to study this webinar. SaaS is a layer on SOA applications, in which SaaS means software as a service. SaaS is hosted on a server and have to be consumed by a browser or a Web 2.0 client, and can also be consumed by other services. Now, what really SaaS is, it is the main definition of SaaS is that it is hosted somewhere. Now, SaaS can also be consumed using SOAP protocol or REST protocol, but there is no restriction how the client consumes the SaaS service. The main thing for SaaS is that it is hosted somewhere. And underlying the SaaS service is a big cloud computing, which the client, the consumer of the SaaS, never sees how a SaaS application is developed. Behind the screen, what I would say is a complex application based on service-oriented architecture and grid computing. Combined is called as cloud computing. And as you can see, that there is a consumer requesting a service, and the service consumer here passes through different routes to produce a result for that request, and which eventually passes through HTTP. And this SaaS application is basically an application running on a server for consumption based on HTTP. Now, an example for SaaS is the webinar software itself. The software I'm using to broadcast this webinar may be thought as SaaS application. Salesforce is also another SaaS application. There are many SaaS application vendors out there who are providing these kind of services. Now, PaaS and POA. Platform-oriented architecture, which is POA, and platform as a service, just cloud computing, marketing differentiation terms. Now, cloud computing, as I said, that includes the hardware. Now, platform as a service provides that hardware as a service. So if we have that hardware and we have implemented a software stack on it, then what we are providing is a hardware with software as a service. So platform as a service provides somebody to get the hardware from the hardware vendor, in which many software is already hosted, and somebody simply have to add their own software to complete the solution. So platform as a service have the hardware also offered as a service, and software offered also as a service, in which the software, some of the softwares are built into it. Here is an example. Let's say that we would like to offer a data synchronization service. To offer data synchronization service, we need a hardware. We can go to Amazon and get a virtual machine. We can buy a EC2 virtual machine as a service and install Oracle there. And in fact, Amazon's EC2 already comes with Oracle installed. So what we are seeing here is that Amazon is providing a hardware with built-in software in it. So that's PaaS, platform as a service. Now what we have to do is add our own application there, because we already have the hardware, which is the operating system, and we also have the Oracle and other software. The required software is there already for as a service. So we do not have to purchase Oracle ourselves. The Oracle is already purchased by the data center, and we do not have to really spend hundreds of thousands of dollars to purchase either one, Oracle hardware or any other application. For example, WebLogic, etc., which is required to host our application. These are already provided by the data center, which is the PaaS, platform as a service. What we are saying is the platform includes both hardware and software, and we are offering that in addition to our own software. So all we need is to provide our own software to PaaS. Now, POA is the model which PaaS uses, so it's nothing. I do not really have to explain what POA is. POA is the model which platform as a service uses. Now, Web 2.0 is the most interesting of all the technologies. Web 2.0 is also disappointing. And what really is Web 2.0? It's nothing. What really is Web 2.0? It's very ambiguous. Nobody knows what 2.0 is, because there was never a 1.0. There is no Web 2.0 API. There are no Web 2.0 tools or Web 2.0 servers. There is no Web 2.0 specification. So Web 2.0 is just a hype. What I would say is it's trying to differentiate a slow load, refresh, reload kind of website with a more dynamic JavaScript, Flash, applets, and plugin-based websites or web application. So Web 2.0 is basically trying to come up with a much more friendlier and more application-oriented websites than traditional websites, in which it's more like a refresh reload type. And most of the websites are becoming like that, more interactive. For example, Google Maps. People have used Google Maps now. It's more interactive. Yahoo email have become more interactive. So people are calling Web 2.0 as those web applications in which it acts, the web browser itself acts as an application. The website itself acts as an application instead of just a website to display, download, and upload information. The Web 2.0 is to define a borderline between two different kind of sites, in which the site itself can be considered as an application. then why do we have Web 2.0? This covers what I just said a few minutes ago, that the cloud client have to be dynamic. That means that someone who is trying to consume cloud application may be using their browser to consume the application. Examples are this application that I am using to broadcast this webinar, Salesforce application, and there are many such applications out there which require cloud clients more dynamic. Web 2.0 is one such requirement, is to have a cloud client which is more dynamic, consumed over the web browser, interacts frequently with cloud applications. On the bottom part, or on the underneath, on the background of a cloud client, which is usually the web application, it have to communicate with the cloud applications, which is usually the services, interactively. So as, for example, the user moves the mouse, the cloud application have to communicate to their services as the mouse moves. So it have to be much more dynamic at real time. So data have to be exchanged at real time. So Web 2.0 are dynamic web applications. Frequency of interaction is more with the user and the application. Cloud application may interact directly with cloud clients. That means that because some of these applications are written using some of the local API, platform-specific API, usually Java or .NET, they take advantage of the PC in which it is running, so it can create more interactive, more friendlier cloud clients that directly connects to the application. An example of this is the webinar software that you're using yourself in your PC, in which you have to download a small application to watch this webinar, which may be a cloud application that GoToWebinar is using. But the bottom line is you are still using your browser. You are not using a separate application. You're still using your browser, and you still have to use your browser to view this webinar. Users do not like web pages refreshing all the time. So Web 2.0, even somebody is not using cloud application, dynamic websites are more preferable than refresh, reload type of websites, because they just waste resources and time. And resources are like bandwidth. Refresh and reload takes more time and more bandwidth. Web 2.0 is an attempt to differentiate websites written for the cloud applications consumed over the browser, which I already explained. And Web 2.0 does not introduce any new technologies. It's just a guideline on how to create a more friendlier browser-based application. I'm sorry, for some reason this screen is getting stuck. So let's move to slide number 17. We are coming close to our discussion. So let's see what are the confusing terms and what are the not confusing terms. The confusing terms were these, and these are the terms that are real. Service-oriented architecture is a real thing. Grid computing is also a real thing that has been there for a while. Cloud computing is a composition of SOA and grid computing. Web services is a specification, and REST is a model to develop software. SaaS is derived from these. PaaS is derived from both many of these. And web-oriented architecture is simply limiting service-oriented architecture to the web and REST protocol. Again, the screen stuck. Slide number 18. These equations are usually used to explain what the relationships is. Doesn't have to be very, you do not have to memorize this or anything. You can and just visualize this. Cloud computing is composed of grid computing and service-oriented architecture. Service-oriented architecture is web services, REST, CORBA, and other service-based technologies. Software as a service is SOA with, this means with, HTTP and web. Web-oriented architecture is SOA with HTTP and REST. Platform as a service is cloud computing plus application, in which application means that we have to provide like a different application, enterprise application like Oracle, WebLogic, databases, and different application into the cloud environment, and then offer that both combination hardware and the software together as a service. And platform-oriented architecture is the model that is used by PaaS. And in this slide, I'm explaining what really service-oriented technologies integration look like. Whether somebody is using web services, REST, SaaS, PaaS, CORBA, web application, or just simple old legacy application, it does not really matter. They can all be interacted with XML as the protocol and XML as the data format. And here you can see the middle arrow is the enterprise service bus, which we discussed, that imaginary bus when we discussed about the imaginary line in the cloud. This is the line I was talking to. This is the line I was referring to, and you can see that all the application based on different technologies are now able to communicate using enterprise service bus, regardless of what its underlying technologies, as long as they put in XML layer on their endpoints and then communicate using the enterprise service bus. In a cloud application, cloud applications are written based on SOA concept, and SOA requires that each applications be written based on layers. So a large complex application requires many layers. And in this example, we are seeing that A and B services, which is this one, A and B, is composed of 2 layers. And the different dependencies of each of these layers, it does not really matter. What matter really is each of these layers, you can see here, are independent services and may not be in the same server. It can be globally distributed in maybe another server in another company, or hosted by another using another technology. So cloud applications are made of heterogeneous SOA applications. Screen stuck again, sorry. Now, objectives of a cloud application is not just cloud application, probably service-oriented orientation, is that all the objectives, service-based service technologies, is to build and host services to solve a business problem. The reason we are hosting an application as a service is to solve a business problem. And there are business clients which must be using these services. If the business problem, the solution, is not being consumed by the clients, then it's useless. So when a service-based software is to be written, its utility as a service have to be thought first. SOA is used to build solutions to the business problem. Cloud application you use to host these SOA solutions, which is covered in a few slides before, in which we discussed that SOA applications are based on layering. Cloud clients are developed to consume the SOA solution services. Now, based on what technology is used to build the SOA application, it may be web services and REST. We have to also provide the clients for them so the consumer can build application based on those. Objectives are met if all of the above is answered by the service. Now, in conclusion, before I finish this webinar and go to the question and answers session, the conclusion is that new terms you will see over years, you will see new terms being added, and new words are derived from these, as we saw in the PaaS and then POA, WOA, all these. But the most basic technology of all of these are SOA plus cloud computing. These are older and more known technologies based on which other terms are being added. So anything that you see, any terms that is expanding our knowledge of other terms, is based on service-oriented architecture and cloud computing. Grid computing is already there inside cloud computing. The cloud computing attaches both SOA and grid computing into one platform, and that's why we can just say cloud computing itself. But the reason I have also added SOA is because SOA is also the client part, and client uses SOA for building clients itself. Now, this concludes slides. This is the last slide, and if you have missed our previous events, there has been a number of events that has been conducted in various topics. You can go to soalib.com and sign up and view the recorded webinars. Some of the webinars are recorded, some are going to be uploaded in a few weeks, and this one also will be uploaded in a few weeks. What we usually do is we record this webinar and then do some editing so that the file size and the video size, audio, and all this becomes smaller and becomes more bandwidth aware. If you have interest in more webinar offered by Soalib, you can go to soalib.com event.html, which is the first line you see here in this site. And we frequently offer webinars and also seminar, online seminar, offline, on-site seminar, and also on-site courses. If you have any question about this webinar and any other question related to Soalib, and also about anything about or you want to ask questions later to me, you can send email to soalib@soalib.com, and I will try to get an answer for you. My direct email is e@soalib. Sorry. Jamil, Jamil @soalib.com, and that's directly sending any question to me, or you can also send it to this site. So that concludes our webinar for this, and this is now time for question and answer. Let me know if you have any questions which I can answer. All right, so thank you for attending this webinar, and have a good rest of the week. Thank you.